I am Anil Kumar. Let me thank all the viewers and subscribers for watching my videos, posting excellent remarks, and sharing some good questions. Here are 3 questions from one of our subscriber, Mr. Siddiqui. Mr. Siddiqui, thanks a lot for sharing these questions, and I hope their solution will help many others. So I'm going to solve these questions one by one, then we'll compile them into one video and post. I also understand that you now will be having your final exams, so solutions for these videos will definitely help you. So let's begin with the solution of the very first question, where we are going to solve a simultaneous trigonometric equation. The equation here is: solve the system of equations in the domain minus 2 pi to 2 pi, where y equals to cos square x and y equals to sine square x plus half. We'll do it algebraically. You can actually sketch the graph and also find the solution, right? So we are given 2 equations. One is y equals to cos square x. The other one is y equals to sine square x plus half. Now what we can do here is we can subtract one from the other. So let's say this is equation number 1 and that is our equation number 2. So if I do equation 1 minus equation 2, in that case I get 0 equals to cos square x minus sine square x, and that also becomes minus half. Correct? So that's what we get. Now we know an identity which relates cos square x and sine square x. So I'm going to take minus half to the left side. So I'll write this as half equals to cos square x minus sine square x. So I hope you remember the identity of cos 2x. Cos 2x is basically cos square x minus sine square x. Correct? So we are going to use this identity here. So we get half is equal to cos 2x. So now it is a simpler solution. You can always pause the video, solve it further, find the answer, and then check with my solution. But there is a trick to this. Still, some of you can get it wrong. See, now we'll work on the domain itself. As far as the domain is concerned, we are saying that x is between minus 2 pi and plus 2 pi. But in the equation, we have 2x. So we need to multiply this by 2. All the 3 terms, we get minus 4 pi to plus 4 pi. So that becomes now the domain for 2x, right? Now cos 2x is equal to half. So what is the value of 2x? Well, let's use our special triangle. So we have to work in radians in this case, right? So if this angle is pi by 3, we know these sides are 1, 2 and square root 3. So that means we have the solution of cos 2x being positive half in 2 quadrants. One of the quadrant will be quadrant 1. The other one has to be quadrant 4, right? So these are the 2 quadrants. And the value for 2x is going to be either pi by 3 or minus pi by 3. Is that clear to you, right? So plus and minus pi by 3, correct? So what we get from here is that 2x should be equal to plus minus pi by 3, right? Now this value of plus minus pi by 3 is when you're looking into the domain which is between plus and minus pi, right? But the domain here is minus 4 pi to 4 pi, correct? So what should we do? Well, we need to add 2 pi to each term, right? Okay. Also look at it in this fashion. If I add 2 pi to this is plus and minus, So in that case, let me rewrite this. Let me write 2x as equal, we'll do plus minus later, right? So if I go in this counterclockwise, we get pi by 3 and 5 pi by 3. So let me rewrite. So we'll do pi by 3 and 5 pi by 3. Now this solution is when we are going in this direction, and so it becomes from 0 to 2 pi. Now if I have to go to 4 pi, I have to add 2 pi. You understand, right? So adding 2 pi means, here if I add 2 pi, that means 6 pi by 3, right? So we get 7 pi by 3. And 6 plus 5 gives you 11 pi by 3. Is that clear? So we get these two also, and that is when we are going in this direction from 0 to 2 pi. Now when we cover in that direction also, then we get minus of these. So I'll write like this. So that is better to understand. Is that clear to you, right? So instead of working like that, we'll work like this. So I hope it is understood. So within this domain, the value of 2x should be plus minus pi by 3, plus minus 5 pi by 3, plus minus 7 pi by 3, and plus minus 11 pi by 3. How about the value of x? So x will be half of these, right? So we'll plus minus pi by 6, plus minus 5 pi by 6, plus minus 7 pi by 6, and plus minus 11 pi by 6. So we have 8 solutions. Do you see that part? So these are the 8 solutions for our question number 1. So I hope that is absolutely clear. A bicycle has wheels with diameter 60 centimeters. The bicycle moves along the road at a speed of 6 meters per second. The outside of the tire has a speck of paint on it. Determine an equation for the height h meters of the speck above the road as a function of time t seconds. Assume the speck is at the lowest point h equals to 0 when t equals to 0. What is the height of the speck of paint when the bicycle has traveled 55 meters? You can always pause the video, answer the question, and then look into my suggestions. So let's try to sketch the scenario. Let's say that's the wheel we are talking about. We are given that the diameter of the wheel is 60 centimeters, right? So that is the center of the wheel. So 60 centimeter diameter means that the amplitude is 0.3 and 0.3, right? So that is the radius, correct? So we know that the diameter is 60 centimeter, which means radius is 30 centimeter, or we can say radius is 0.3 meters. So it's kind of important to convert the units to meters, since we have speed in meters per second, right? Okay. We are also given here that we need to find the movement of this speck, right? Which is right at the bottom at t equals to 0. So as it moves, then the speck will move upwards. So here the time is moving, right? So what we get here is a function which is going to be kind of like this. You understand, right? So that is how we are going to get our wave, where this is along a road, right? Let's try to understand. So it is along a road, kind of like this, correct? So that is one particular wave, one complete cycle. We need to write equation of this cycle. Perfect? Okay. Now, how do we get that? Okay. Now, let's also understand that one rotation means, because this whole distance is how much? That is what we are interested in figuring out. Now, this one cycle means circumference. So from here, the distance is from 0. This distance should be equal to circumference, right? So this distance, which we will see let's call this as S. The distance traveled will be 2 pi r, right? 2 pi times radius, which is 0.3 in meters, correct? So this distance or displacement horizontally along the road will be 0.6 pi meters. Is that correct, right? So that is the distance. Now that is one cycle, right? So this is distance for one cycle. So this is one cycle. Basically will take this point through one full circle, right? And horizontally on the road, the car or the bicycle in this case will travel a distance of 0.6 pi meters. Clear? Now what we need to find is one cycle time. We have to find time for one cycle, right? So how can we find that time? Now clearly the speed is given to us as 6 meters per second. We need to find time for 0.6 pi meters, correct? So time, which is the time period for 6 meters is 1 second, right? So for this much it is going to be 1 divided by 6. That is the distance and this is the velocity. So we'll divide the distance, which is 0.6 pi, by the velocity, right? So distance divided by time. So you should know distance divided by speed is time taken, correct? So distance traveled is 0.6 meters and the speed is 6 meters per second, right? So that much meters, the speed is 6 meters per second. So we get time in seconds as 0.1 pi second. Is that clear to you? So that becomes a time period t. Now once you find the time period, then we can actually easily find the equation, right? So let's find the equation now. Let's say this at any instance of time on the y-axis, we have the height of the speck. So that was the speck, right? So height of the speck, h of t, is going to be, since it is a cosine function starting with the minimum, normally cosine starts with maximum, we'll write this as minus. The amplitude here is 0.3, right? So that is the axis, correct? That is the axis. The amplitude is 0.3. Cos of k, the value of k will be how much? K is, now we can find k here. So time period is 0.1 pi. So k will be equal to t by 2 pi, right? So let's find k before writing this. K is equal to time period by 2 pi. In this case, time period t is 0.1 pi. We are going to divide by 2 pi. So pi and pi cancel. So we get 1 over 20 we can write, right? So 0.1 over 2, better to write as 1 over 20. So that is the value of k. Okay. So we substitute this value of k here, which is 1 over 20, right? So we get 1 over 20 t. Plus this is 0.3 above the ground, the axis, so 0.3. So that becomes the equation, correct? So I hope the equation is absolutely clear. So we have squeezed in all the information in a small area. So at t equals to 0, we'll get minus 3.3 plus 0.3 as 0, so that works, correct? So we have done part A of writing the equation, and in part B, what is the height of the speck of paint when the bicycle has traveled 55 meters? Now, when bicycle travels 55 meters, we have to see what time it takes, correct? So we know time taken will be 55 meters divided by the speed, which is 6 meters per second, right? So that is what we are going to get. So we'll get 55 by 6 seconds. So that is the time. So let's find the height when the time is 55 by 6 seconds. Clear? So we need to substitute that here. So we get minus 0.3 cos of 55 over 6 times 2 is 120, right? So we substitute this value plus 0.3. So let's use the calculator to find this answer. We should set this to radians. That is another important thing whenever you're working. For me, 4 is radians. So now we have 0.3. I'm writing this first. 0.3 minus 0.3 times cos of, within brackets, 55 divided by 120, which we got by multiplying 6 by 20, right? 120, bracket close. So that is what we have, equals to. So we get this as equal to 0.03, right? So that is the height in meters for the given spec when the distance traveled is 55 meters. Correct? So our answer here is that the height above the ground will be 0.03 meters, right? So very close to the ground. Correct? So that is how you're going to solve this question. I hope you understand and appreciate it. So let's go through it once again. First, your setting of calculator should be in radians. Now, diameter is 60 centimeter, which is same as 0.6 meters divided by 100, right? So this is equal to 0.6 meters. So the radius or the amplitude in this case would be 0.3. So we get 0.3 here. Since the curve starts with the minimum minus cos function, time period t is calculated by speed, we know is 6 meters per second. Distance traveled in one cycle is 0.6 pi. Dividing 0.6 pi by 6, we get a speed of 0.1 pi. Right? So time period of 1.1 pi for one cycle. Now k is equal to t by 2 pi, and so we calculate the value of k as 1 over 20. So we get the function h of t is minus 0.3 cos 1 over 20t plus 0.3. Substituting, we get our solution as height will be almost 0.03. It will be very close to the ground. So that is how you could answer this question. We'll sketch the graph of the function y equals to cosecant half of x minus 3 pi by 4 plus 3. We'll also state the domain and range. Now let's try to understand this. Cosecant is a reciprocal of sine, so I could also think about writing this as 1 over sine of half of x minus 3 pi by 4. And then we will translate it 3 units up, right? So that is going to be our strategy. So in step number 1, let me say we are going to sketch the graph for sine of half x. So step 1, we are going to sketch graph of sine of half x. Correct? Step 2, we'll translate it 3 pi by 4 units to the right. So that is to say, we'll sketch sine of half x minus 3 pi by 4. Okay. And in step 3, we are going to sketch the reciprocal of this. That is to say, we'll sketch cosecant half of x minus 3 pi by 4. And finally, in step 4, we are going to translate it 3 units up. So we'll get the graph for cosecant half of x minus 3 pi by 4 plus 3. Is that okay? So final graph will be our step number 4. So that is how we'll move in a sequence to understand all the concepts. let's say this is our y-axis. And how many units we have? 1, 2, 3 I could take, 4. Okay, so we'll take this as our x-axis. Okay. First step, of course, is we have sine of half x. What is the time period t? So time period t for this function will be 2 pi by half, correct? So that gives us 4 pi. So 4 pi is the time period for the function sine of half x. Now, since we have to translate 3 pi by 4, I am going to actually divide pi into 4 equal parts. So 1, 2, 3, 4. So that is going to be our pi, correct? So this is going to be pi. So 1, 2, 3, 4. That is going to be 2 pi. 1, 2, 3, 4. 3 pi. 1, 2, 3, 4. 4 pi. 1, 2, 3, 4 will be 5 pi. So let me write here. This will be our pi. 2 pi. 3 pi. 4 pi. One time period. 5 pi. So I'll just sketch one cycle. To get sine of half x, our amplitude is 1. Let this be 1 for us and this be minus 1 for us. Clear? So that is going to be starting with 0, maximum, 0, minimum and 0. Correct? So that is how the cycle is going to move. And now joining these points, we should get our graph, right? So we have here starting with 0, maximum, 0, minimum, 0, right? And then again, it will move to maximum at 5 pi. So let me sketch this portion so we get this graph. Time period being 4 pi. Clear? Okay. So we have got the first part of it, which is sine of half x. So this is sine half x. Clear? Now the next part is translating this 3 pi by 4 units to the right. Okay. Now 1 pi by 4, 2 pi by 4, this is 3 pi by 4. So these points are going to shift 3 pi by 4 units to the right. So that means 3 units to the right, kind of like this. You're getting my point, right? So every point here, so we have a curve this time, which will be like this, right? So this point 1, 2, 3 moves there. So we have a minimum here, this, right? This point 1, 2, 3 will move here. So we have a maximum 0 here, and then this is going to continue. Is that clear to you? So this graph is the second graph where we have translated the sine function 3 pi by 4 to the right. Is that clear? Now let's look into the reciprocal part. So when we are talking about reciprocal, clearly at 0 we'll get a vertical asymptote, correct? So these are the vertical asymptotes. They are not part of our domain. So that is a restriction for the function cosecant x. It's a periodic function, so we'll have both sides the same thing. Correct? So, well, if you want to complete this, 1, 2, 3, 4, it will have minimum at this point here. Correct? Okay. So we have our sine function, we have these vertical asymptotes. Clear? Now, looking into this cosecant function, which is reciprocal of this, means reciprocal of 1 is 1, right? And half will be 2. Okay? So accordingly, this graph will be, so for sine, half is at pi by 3, 6, right? So pi by 6 anyway. So now we have moved. So pi by 6 kind of here will be half. So we'll go approximately. So from here we can go like this. So that is cosecant function, correct? So on this side also negative portion will have from here coming downwards. Now this is kind of not in our scale, but I hope you understand how we are going to draw it. Once we shifted 3 units up, this will be absolutely clear. Is it okay? So we have our reciprocal function, and now finally let us get our function y equals to cosecant half of x minus 3 pi by 4 plus 3. Means we are going to use translation of vertical translation of 3 units. So this will go to, from 1, it will go up by 1, 2 and 3. So this point here will now move to this point. So we have a graph here which is going to be moving upwards from here, which is the point at 1, 2, 3, 4. Is it clear? So from here, this is a vertical asymptote. So we have a graph which will be kind of like this. Is that clear? So this is the positive half. On the negative half, the axis of the graph will move from 0 to 3. So 1, 2, 3. So that is the kind of our axis now. The negative portion can now be very clearly seen. So that is 1, 2, 3 parts here will be going up to 2, right? So moving 3 up. Here it was negative 1. So that is going to be like this. Is that clear to you? Right? So in this case, maximum will be around this point and it will look like this. Is that clear to you? So the graph in green is our final function and these are the steps to be followed. Is that clear? That is how we are going to sketch the graph of cosecant half of x minus 3 pi by 4. You can also find the coordinate points, do the translation and get your graph. But I hope you understand and appreciate this particular method. So here, first we found the time period, which is going to be 4 pi. We sketched the sine function with a time period of 4 pi, translated this 3 pi by 4 to the right, and then sketched the reciprocal of that, marking the vertical asymptotes at the x-intercepts. Positive half remains positive, negative remains negative. Then we translated that 3 units up to sketch the final graph. Perfect. Now we can write domain range. So as you can see here, the domain is all real numbers except these points, right? So 3 pi by 4 is not there, plus we do not have 2 pi plus 3 pi by 4, right? So we in our 2n pi plus 3 pi by 4. So basically s is not equal to 2n pi plus pi by 4. Is that okay? So the domain can be written as x belongs to real numbers so that x is not equal to 2n pi plus 3 pi by 4. Those are the vertical asymptotes. Now as far as the range is concerned, range, as you can see, after the translation by 3 units up will be y belongs to real numbers where y is either greater than or equal to 4 or y is less than or equal to 3 2, right? So this is 2 for us. as we move 3 units up. That is going to be the range. So that is how we are going to define the range. So I hope that is absolutely clear. Feel free to write your comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for watching and all the best.